Hello, everyone. Thank you for joining us today. Today, we'll talk about how you can accelerate application development with real-time streams in Amazon Redshift. My name is Ripunjay Patnaik. I'm a solutions architect here at Amazon Web Services. I also have Uday Narayanan, solutions architect, joining me today. So this is our plan for today. First half, I will talk about the challenges and the business opportunities with data, the need of streaming ingestion and the challenges with it, new feature with Amazon Redshift, capabilities, benefits, and some of the real world use cases. And finally, they have a wonderful demo to showcase the newly introduced Redshift streaming ingestion feature. So let's get started. In the modern world, only the most informed succeeds. The one who have direct access to their data make better, more informed decisions, respond faster to unexpected, and uncover new opportunities. Analytics requirements are now coming in from all the corners of the enterprise, and the data set for the customers have increased from terabytes to petabytes. And now we see with even exabytes of data. This data is stored in various data sources, in relational, non-relational databases, in data lakes, within data warehouses. Now each department and each region is creating their own data. So the question is, how can we harness this data? And how do they make sure that the performance is not degraded when data grows so quickly? How can we scale the systems to meet the capacity without impacting the performance and the price? So these are some of the questions that the customers have in their mind. In addition to this, data users within the organizations are growing like never before. In past, business leaders were going through the data engineers for most of their analytics needs. And the developers were asking the database administrator to manage the data warehouses for them. And that was the old paradigm, which doesn't work in the modern world anymore. So everyone wants fully managed, self-service, zero-touch analytical system to leverage data as part of their day-to-day job to derive faster insight. So now let's talk about streaming data. Why streaming data? So the data that is generated in many modern systems loses value over time. The most common example is credit card transaction system, where early fraud detection has enabled companies to dramatically reduce the impact of fraud within their business. And there are plenty of other examples, from customer experience optimization to IoT preventive maintenance. According to Forresters, insights from data are perishable and can lose value quickly. Stream processing allows analytical insights to be gathered and acted upon instantly. Batch processing data doesn't allow for real-time risk mitigation or customer authentication. And the customer experience can be ruined and is hard to recover if action isn't taken in real time. So acting on real data can help prevent fraud and increase customer loyalty. Untimely data, on the other hand, can inhibit your firm's ability to grow. So there is a canonical streaming data flow that comprises of the following stages. If you look across any sort of use case, you would see components conceptually falling under these stages. If you go from left to right, you have a source, which can be a mobile application, application log, IoT sensor, smart buildings, web clickstream, connected products, smart buildings. So these are the ones that sources that produce the data continuously and at high velocity. Then you have a streaming mechanism that can collect the data from these tens and thousands of data sources, and then it can ingest it in the real time. Then you need a streaming storage where you could store this data in the order it is received, and it can be replayed indefinitely during that time. And then you need a stream processing where you could do extract, transform, and load process on the data in real time for your real-time analytics requirement. And finally, this data is stored in data warehouses and data lakes. The data stream is challenging to set up and get it ready. When you self-manage and run a streaming platform, you need to provision servers, configure servers manually, and make sure the configuration is applicated across all nodes in a distributed cluster. Replace server when they fail, perform server patching, upgrade, make sure the server is architected for high availability, make sure the data is durable, stored, encrypted, and provide security authentication and authorization to the clusters. You also need to set up monitoring and alarms and carefully plan scaling event so as to support the load challenges, which itself is a tricky process. So all of these require a lot of expertise, time, money to operate and maintain. So now let's talk about what are the requirements from this modern data warehouse. So if we combine all the requirements that we spoke about earlier, a modern cloud data warehouse has to deliver analytics without compromises. So customer need to analyze all the data without moving it, support all popular open standard file formats such as Parquet, OD, JSON, and access the data seamlessly across their data warehouses and operational databases. They do not want to think about provisioning and operating their data warehouses or managing their workload. So customer workloads are unpredictable and diverse, and the system should deal with it without manual interventions. They want the system that stays within their budget and doesn't incur cost when the system is idle. Customers want top-notch price performance to make it affordable in the face of ever-growing volume of the data. And finally, they want it to be real-time for thousands of users accessing it simultaneously through the business intelligence tools. And that's why Amazon Redshift. So the most widely used and affordable cloud data warehouse has been investing and innovating along all these areas to meet the customer challenges and address their modern needs. It helps you analyze all your data, your log files, your transactional data, your clickstream data, semi-structured or nested data without movement or transformation. It is the most affordable cloud data warehouse that delivers up to 3 times better price performance relative to the competition. It requires zero administration and reliably delivers insights from your data in seconds in a more secure way. So now let's talk about Redshift streaming ingestion. So we heard from the customer that real-time analytics is a requirement. And then we launched Amazon Redshift streaming ingestion for Amazon Kinesis data stream, which enables you to ingest data directly from Kinesis data stream without having to stage the data in Amazon simple storage service. Streaming ingestion allows you to achieve low latency in order of seconds while ingesting hundreds of megabytes of data into your Amazon Redshift cluster. So currently, if you want to combine real-time data with the data available in your warehouse, there is a pipeline that you have to build. Like first, you will read those data from Kinesis data stream, then stage the data in Amazon S3, and then run Redshift copy command to ultimately send those data to your data your warehouse. Usually these pipelines latency is in minutes. Now with the new feature, you do not need to maintain a separate pipeline to send your streaming data to Amazon Redshift. You just connect with Kinesis data streams, creating a materialized view in Amazon Redshift, and let the engine populate your data warehouse automatically. This way, you can achieve very low latency, near real-time analytics with your existing data warehousing engine like Redshift, process streaming data easily using SQL, and visualize those with your preferred BI tools like Amazon QuickSight, Tableau, or Power BI. Now let's talk about some of the benefits. So one of the key benefits is definitely high throughput with low latency. Amazon Redshift can handle and process several gigabytes of data per second from Kinesis data stream. So this allows you to experience low latency and high bandwidth when consuming the streaming data. So you can derive insights from your data in seconds instead of minutes. Setup is a straightforward process. All the setup and configuration in Amazon Redshift uses SQL, which is the most cloud data warehouse users are already aware of. You can get real-time insights in seconds without managing the complex pipelines. Amazon Redshift with Kinesis data stream is fully managed. You can run your streaming application without requiring any infrastructure management. Increase productivity. You can perform rich analytics on streaming data with Redshift and using the existing familiar SQL without needing to learn new skills or languages. You can create other materialized views or views on materialized views to do most of your extract, load, transform data pipelines within Amazon Redshift using SQL. So how does it work? What is the architecture behind it? Amazon Redshift ingestion works by acting as a stream consumer. A materialized view is the landing area for the data that is consumed from the stream. When the materialized view is refreshed, Amazon Redshift compute nodes allocate each data shard to a compute slice. So each slice consumes the data from the allocated shards until the materialized view attains a parity with the system. So the very first refresh of the materialized view fetches the data from the stream. Subsequent refreshes read the data from the last sequence number of the previous stream until it reaches the parity with that data stream. Now, setting up the streaming ingestion in Amazon Redshift is a two-step process. You first need to create an external schema to map Kinesis data stream and then create a materialized view to pull the data from the stream. The materialized view must be incrementally maintainable. And this is what Uday is going to show us in the demo, which is we are going to see later. So these are the common real-time use cases. One is improving the gaming experience. So as we know that any gaming application produces a lot of data in the real time. So with streaming ingestion, you could focus on in-game conversation, player retention, and optimizing the gaming experience by analyzing the real-time data from the gamers. Analyze clickstream user data for online advertising. The average customer visit dozens of websites in a single session. Yet, marketers typically analyze only their own websites. Analyze authorized clickstream data ingested into the data warehouse to assess your customer footprints and behaviors. You can use Amazon Redshift with Amazon Kinesis for real-time application, such as application monitoring, fraud detection, live leaderboards. You can ingest the streaming data with Kinesis data streams, process it with Kinesis data analytics, and emit the results to any data store or application using the Kinesis stream with millisecond end-to-end latency. Real-time retail analytics on streaming point-of-sale data. So access and visualize in real time all your POS retail sale transaction data for real-time analytics, reporting, and visualization. Deliver real-time application insights. So with the ability to access and analyze the streaming data from your application log files and network logs, developers and engineers can conduct real-time troubleshooting of the issues, deliver better products, and alert systems for the preventive maintenance. So this is actually one of the examples where one of our financial service customer in Asia, they use Amazon Redshift streaming ingestion feature. So they had an automated system to control risk of the firms related to the financial functions, such as recharge, consumption, ROR, refunds. So this system consists of a report that includes the user behavior record and the risk control rule engine. The user behavior is automatically evaluated by the engine to allow or deny a user based on the rules defined in the rule engine. So customer uses Amazon SageMaker in their artificial intelligence-based risk control engine that mainly provides risk control decisions for credit card users in North America for recharge and the refund behavior. The report contains trained chats, ranking icons, showing the rule hit rate, intercept rate, top hits, and other information. So the core storage of the risk control uses OpenSearch and Amazon Redshift. The rule engine streams the data to Kinesis data stream and is added to Redshift via Redshift streaming ingestion, and the risk report comes from the Redshift in near real time. So in past, the customer was able to view the control reports for data on hourly basis. Now with streaming ingestion feature with Redshift, they can now view the risk report in near real time. This significantly improved their business efficiency and helps them to evaluate the actions from the control engine faster. So now Uday is going to show us a demo. Uday, please take it from here.
Thank you, Ripu. Hello, everybody. My name is Uday Narayanan, and I am a solutions architect at AWS. In the next few minutes, we'll look at Amazon Redshift streaming ingestion in practice and see how it works with a quick demo. For our demo, we'll be looking at a use case where we are getting some sales data that is being streamed in through Amazon Kinesis data stream. And this data needs to be available in Amazon Redshift with low latency and high throughput for downstream analysis. So we will use the Amazon Redshift streaming ingestion feature for this. With this feature, we don't need to have any preliminary staging in Amazon S3. And streaming ingestion provides low latency, high speed ingestion for stream data from Kinesis data streams into Amazon Redshift. So first, let's go into the Kinesis page on the AWS console. And here we have a Kinesis data stream that I have already created for this demo. So if you look at the configuration, it's in an on-demand mode. It has the read and write capacity as shown here. And then it has a default data retention of 24 days. With Kinesis, you can actually go up to 365 days if you need additional data retention. Right. So next, let's look at what data we are sending into our Kinesis data stream. For this, and for this particular demo, I'm using the Kinesis data generator. It uses the Python Faker library to create data that can be streamed into Amazon Kinesis. So in this case, our data looks like this. It's, as I said earlier, it's sales data. So we have a quantity, price, order status, country, customer ID, and order date. And for now, I'm simulating data for all of the dates in August so far. If I do a quick test template, we can see what the data looks like. So again, we have the quantity, price, order status, country, customer ID, and order date. And if you would like to learn more about the Kinesis data generator, I mean, we have a lot of good information in the help and documentation around it. So I'm going to start sending data to my Kinesis data stream. So in this case, I'm saying that my Kinesis stream is in US East 1, and this is the name of the Kinesis data stream that we just saw on the Kinesis page. And I'm sending 10 records per second. All right, so let's start sending the data here. Now, next, let's go to Amazon Redshift query editor. So, this is on the Amazon Redshift page in the console. If you click on the query editor, it brings you to the Redshift query editor. So in order to bring data in from Kinesis into Amazon Redshift using the streaming ingestion feature, the first thing that we need to do is create an external schema from Kinesis. So to do this, we first give the external schema a name. In this case, I'm naming it stream demo. Next, we need to specify that this external schema is from Kinesis. And then finally, we need to provide it with an IAM role. This IAM role is what Redshift will use, or it will assume this role to access the Kinesis data stream. So this IAM role should have the permissions to list the streams as well as to read the data stream where the sales data is coming from, right? So with that said, let's just quickly run this. Great. The next command here, it's pretty much like we are saying we want to enable case-sensitive identifier, and this is because the Kinesis data stream names are case-sensitive. Okay. The next step is, we need to specify which Kinesis data stream we want to ingest into Amazon Redshift, right? So your account can have multiple Kinesis data streams. So we want to specify which Kinesis data stream you want to ingest. And we do this by creating a materialized view in our external schema from our Kinesis data stream that we want to ingest from. So now let's look at the query for the materialized view, right? So the first line here is pretty much saying create materialized view, and we are naming it as sales data. And then we have these 4 columns and the payload. So the first 4 columns here, these are metadata columns that are available for all Kinesis data streams and can be used for troubleshooting, monitoring, and auditing purposes. The payload column is where the actual data of the data stream is coming from. It is in the JSON format, and we can ingest this payload into Redshift in 2 ways. The first is where we can ingest the entire payload into a super data type column in our materialized view. You can use this approach if you do not know the schema of the incoming data and hence want to bring in all the data first and then parse it as a second step. And that is what you're seeing in this particular query here, right? So let's just run this query. I forgot to mention the from clause, like this is where you specify which Kinesis data stream you're ingesting from, right? So this Redshift streaming webinar, this is the name of the Kinesis stream, which if I go back to the Kinesis console, you will see that it matches this, which is pretty much telling that, okay, we are ingesting the data from that particular Kinesis data stream. So one thing to note is creating the materialized view will not populate the data. So if I run a select command on or select statement on the sales data materialized view, you actually do not get any rows back, even though the view was created. So for it to populate the data, we actually need to run the refresh materialized view statement as well. When we do the refresh, the data is pulled from the Kinesis data stream into Amazon Redshift. All right, so let's run this. So usually, the first time this runs, it can take a little longer depending on how many records are present in your Kinesis stream, because it is reading all the records from the beginning of the stream. Subsequent refreshes will only pull the new data that have come in since the last refresh. So once the payload has been pulled into the materialized view and all the data is available, if I rerun this query, we'll start seeing some records back, right? So as I said, the first few columns are just metadata columns. The interesting information is right here. So we have the same thing that we saw in the Kinesis data generator earlier. We have the quantity, price, order status, country, customer ID, and so on. And all of this is in a payload column, which is of the super data type. So next, once this data is available, we can extract this JSON and make them as individual columns. And this is just like a normal process where you extract the JSON data, right? So in this case, like this particular query, I'm extracting the different attributes of the JSON into their own individual columns. So again, we have the quantity, price, and so on. Now, once this data is available, running queries on it is similar to running queries on any other view or table that you would do on Redshift in general. So here, I'm running a query to get the total sales by country. And then similarly, I'm running another query here, which is getting me all the sales by date, with the date being ordered in a descending order. All right. Now let's look at the second method of how you can bring the stream data into Amazon Redshift. So here, you can use this method if you already know the schema of the payload. We will call this materialized view, in this case, we'll just call it sales data 2. And instead of loading the entire payload into a super data type column, we can extract the individual columns using the JSON extract path text command and store them in individual columns in the materialized view. With this method, you can also define specific columns to be your distribution key or sort key, just like you would do in any table or materialized view in Amazon Redshift. Right? So let's just run this. Same as before, just creating the materialized view does not bring the data in. So we need to do a refresh command. So I'll just run this refresh command here, or the refresh statement. And like I said earlier, the first time it can take a little longer because it's reading all the data that's in your stream right from the beginning. All right, and then we'll rerun the same command or the same statement again that we did earlier to get all the sales by date. And again, you get similar results back. Okay, so now let's go back to the Kinesis data generator and stop this. And if I look at here, like right now, we only have data till the 14th of August. So now what we're going to do is I have another template created, which is exactly the same as the previous one, but the order date is hard-coded to the 15th of August. So basically what we are simulating here is that there is new sales data coming in for the 15th of August. And how would that show up in our Redshift cluster? So let's start this and start sending data. All right, so now it's just started sending data to the Kinesis stream. So if I go back into my Redshift query editor, and if I just run a refresh materialize view statement and rerun this particular query, you'll see that the data for 15th August that we just started sending is already available in your Redshift cluster. So with this, like you're almost getting very close to near real time access to the data in your Redshift cluster, and then this information can be used for further downstream analysis as well. So if you're running BI reports on top of your Redshift data warehouse, or if you're doing some kind of machine learning analysis using the Redshift ML feature, getting access to real-time data can be very important for your business. And with this capability or this feature, you can make that happen, and that data can be available in near real time. All right, so now one thing that we have done so far is we've been running these queries manually, right? And we cannot be running these refresh materialized views manually. You cannot have somebody keep running these queries. So we would want to schedule this. So what I have done is I've already scheduled this, like I have already created one schedule where this particular query to refresh the materialized view is running every minute. But I'll quickly show how this works and how you can actually schedule it. So you go to the query editor, which brings you to this editor tab, and then you can write your command here, right? So in this case, I'm saying refresh materialized view sales data 2, and then you can just click on schedule. You need to provide it with an IAM role. So in this case, I'll give it an IAM role. This IAM role allows the scheduled query to assume permissions on your behalf, pretty much. Next, you need to give, provide the credentials to connect to the cluster. So here we provide it with the cluster name, the database, which in my case is dev, and the username, which in my case is AWS user. This name of the query can be pretty much anything, something logical. We already know what the SQL query is that we're running on schedule. And then you need to provide it with scheduling options, right? So you can either do cron, or you can just give it a certain frequency. So you can have it repeat by minute, hour, day, week, or month, and then you can provide like how often do you want it to be repeated. So in this case, I'm going to say repeat every minute, and I want this to run every day. So basically every minute, it's going to run that refresh command and bring the newest data from the Kinesis data stream into your Redshift materialized view. All right, and then we just save these changes. And the scheduled queries show up here. So this is the one that I already had, and this is the one that I just created. Now, if I go back to the query editor, if the last time we ran this, we only had 7,133 quantity for the 15th of August, and we haven't run the materialized view manually since then, right? But the automated portion of it has run a couple of times, the schedule that I had created prior to the webinar. And if I rerun this command, you see that the quantity has changed because the refresh ran a couple of times. It brought in even more data into this materialized view. All right, so that brings us to the end of the demo here. So with this demo, we saw how you can use the new streaming ingestion feature of Amazon Redshift to ingest streaming data from Amazon Kinesis into Amazon Redshift directly. So I'm going to go back to the presentation now, and we'll just talk about the summary and next steps. So basically today we talked about how you can ingest the data from Kinesis data streams using Amazon Redshift streaming ingestion. And as I said earlier, with this new feature, you can easily build and maintain data pipelines to ingest and analyze streaming data with low latency and high throughput. And then once the data is available in your Redshift materialized view, or it's available in your Redshift cluster, you can perform rich analytics on that data. And you can do all of this using just SQL commands, right? So there's no need to learn any new skill or no new programming languages. Essentially, you're using SQL statements to get access or do analysis on your streaming data, which makes it a lot easier to work with the streaming data as well. So where do we go from here? The next steps, I would say, you try out the Amazon Redshift streaming ingestion feature in your own accounts. It's available in preview today, and play around with it. Try it out with your own use cases to see how it works for your specific use case. And if you have any questions or feedback, you can send an email to this particular email ID. And if you want to learn more about this feature, we have a link to the feature page and a blog post which talks about this in a lot more detail, and we'll add that into the chat, the links for those as well. With that, I'd like to thank you for attending the webinar and being with us. Have a great day, everybody. Thank you.